Welcome to our video on solids. A solid is a state of matter that has a fixed shape and volume, but they are not necessarily permanent. Take ice for example. Ice can melt to form a liquid. As mentioned, solids have a fixed shape and size, and this is due to the attractive forces between the atoms or molecules being greater than the energy causing them to move apart. Basically, the atoms or molecules do not have enough energy to move and are stuck together in whatever shape they were in when they lost the energy to move apart or separate. Solids can be made up of one element, pure, or a mixture. There is more than one type of compound in the solid. For example, concrete is a solid mixture. One can also label solids as being a heterogeneous mixture, where throughout the compound there may be different concentrations of a compound dispersed within the solid. Take granite for example. When looking at granite, one area may have a lot of quartz and very little feldspar, but if one flips the piece of granite, the opposite may occur. There are also different types of solids. When looking at a crystalline solid, one sees that the solid is very ordered, and the atoms are in a very specific order. Examples of a crystalline solid are salt and sugar. Amorphous solids are very disordered, and the atoms are held together in a random formation. However, in a crystalline solid, the atoms are held together in a lattice formation and are very ordered. Think about a game of checkers. When the game begins, it is set up with a checker in each square, which is like a crystalline solid. But once the game begins, those pieces that were once ordered are now randomly scattered on the board, similar to the amorphous solid. Crystalline solids have different solid types: molecular, network, ionic, and metallic. When looking at individual molecules, the molecules are composed of atoms that are held together by strong covalent bonds. But when we form a molecular solid, the molecules arrange themselves in a specific pattern held together by a relatively weak intermolecular force. Think of these solids as solids that are made up of interconnected molecules. Examples of molecular solids are ice, dry ice, and table sugar. Molecular solids can be nonmetals, diatomic elements, or sulfur. A network solid has no defined individual molecule. These atoms are interconnected in a vast array by covalent bonds. With network solids, the three-dimensional structure provides information about the compound. For example, diamonds and graphite are made up of the same thing, elemental carbon. But the way that carbon atoms are bonded together, one might have either a diamond, one of the hardest compounds out there, or graphite. These are made up of one or two nonmetals. An example of a network solid made up of two nonmetals is silicon dioxide or quartz. Like molecular solids, the ionic solids have no distinct molecules. The difference is that the ionic solids are composed of positively and negatively charged ions that are held together by ionic bonds. These have a high melting point, low vapor pressure, and poor conductors of electricity. An example of an ionic solid is salt. Metallic solids are shiny and conduct electricity. These atoms are held together by metallic bonds, and the atoms are packed together, but the electrons easily move around. The bonds are non-directional, and this means that the atoms remain bonded while the atoms roll against each other as long as parts of their surfaces are in contact. Solids have many properties. They are good conductors of electricity, malleable, and ductile. The melting point of a solid depends on the strength bond. The stronger the bond, the higher the melting point. To review, solid is a state of matter that has a fixed shape and volume. They can be a pure solid or heterogeneous in makeup. Granite is an example of a heterogeneous solid, and gold is an example of a pure solid. When looking at a crystalline solid, one sees that the solid is very ordered and the atoms are in a very specific order. Amorphous solids are very disordered, and the atoms are held together in a random formation, whereas a crystalline solid, the atoms are held together in a lattice formation and are very ordered. In a molecular solid, the molecules arrange themselves in a specific pattern and are held together by a relatively weak intermolecular force. With network solids, the three-dimensional structure tells about the compound. The ionic solids have no distinct molecules. Metallic solids have bonds that are non-directional. This means the atoms remain bonded while the atoms roll against each other as long as parts of their surfaces are in contact. Solids are good conductors of electricity and malleable and ductile. Thanks for watching. I hope you enjoyed it. For more great and informative videos, please go to and subscribe to our YouTube channel at Ask ASC. Have a great day.